In this video, I'm going to design another function operating on element. Remember that element and list of element are mutually referential types, and so that means designing one function is actually going to end up designing two of them. I'm in fs2-v2.racket, and if I scroll down here to the problem, here it is. Design a function that consumes element and produces a list of the names of all the elements in the tree. So I know right away it consumes element, and I need to know what list of names means. So I'll go back up to the element data definition, and let's see, for an element the name is a string. So this is going to produce list of string, and of course there'll be the function that operates on list of element, and that's almost certainly going to produce list of string as well. Let's do a purpose, produce list of the names of all the elements in the tree. We'll do a couple stubs, all names dash dash element, which consumes E, produces empty, and all names dash dash LOE, which consumes an LOE, produces empty also. So those are the stubs. Run them to be sure they're well formed. They are. There's no test, so they're not running, so they're highlighted in black. Okay, let's do some examples. Check, expect, all names dash dash. Now, which one should I test first? Let's go look at the type comment. Up here at the type comments, what we're looking for is what is the base case. Remember, the base case is a place where the reference cycles stop. It isn't here in element because the only thing that happens in element is make elt of these three fields, and list of element is a reference to list of element. So let's look in here for the base case. Well, here we see that the base case is operating on an empty list of element. Because this isn't the base case, the cons case isn't the base case, that goes in a cycle to list of element, and it also goes back up to element. So an empty list of element is the base case. So now we can go back down to where we're working, and we know that to test the base case first, we're going to start with all names dash LOE of empty. What does all names of an empty list of elements produce? Well, that sounds like empty. We're still not quite certain that this function is supposed to produce list of string, but assuming it is for now, it would clearly produce empty in this case. Let's do another case. We've done the base case, but let's also try to do a simple case now. And what I'm going to do is go back up here and get this figure and copy it down here. It's really great that Dr. Racket lets you do this. You should enjoy it now because not every programming environment will let you do it. So we've tested the empty list of elements case. Let's now check all names dash element of, let's check F1. Well, what are all the elements in the tree starting at F1? Well, it's just F1 because F1 has no sub-elements. So all the names are list F1. All right, let's check another case. Let's check all the names in D4. Well, what are all the elements in D4? Well, there's D4, F1, and F2. So those are the names, D4, F1, and F2. Let's do another one. See, we've done F1. There's no use doing F2 or F3 because they're the same as F1. And there's really no use doing D5 because D5 is simpler than D4. Except maybe we should have done D5 first because it's simpler than D4. It's not much simpler, but it seems a little simpler. So let's do it. And it would produce, what would it produce? Well, it would produce D5 as the first thing and F3 as the second. And now what's D6 going to produce? Well, let's see. D6 Well, D6 has D6 in it for sure. And what else does it have in it? Well, it has everything in D4, which is all of that, and everything in D5, which is all of that. And let's see. These two lists have to be combined, and that has to be put on the front. So one way of saying that is appending those two lists together and consing that single item on the front. You could, of course, just write the value. You wouldn't have to write the elaboration. So you could just write it this way, but the elaboration might be helpful, especially for a case a little bit complicated like that. Okay, let's run it. All names-element is not defined. Oh, I didn't follow my naming convention properly. And since I cut and pasted, I didn't follow my naming convention properly several times. Okay, the tests are all well formed. Let's save this. It's always good to save often. Okay, so let's comment out the stubs, and let's go get the templates. And I'll show you a trick here. If you go right here, you get a list of every definition in the file. So as files start to get bigger, you can jump to individual definitions more quickly this way. And all good programming environments give you a feature like this. So I'll go to Fun for Element, and I'll grab the two templates, and I'll go back down where we were, and I'll get rid of these comments. I'll do the renaming. Remember, there's mutual recursion here, so I have to be careful to get all the references. There's that one, and then there's this natural mutual recursion here. And then when I rename the LOE function, there's the definition, there's the natural recursion, and there's the natural mutual recursion. So I get all those. So now let's work off the examples. The first example tells me that if I call all names LOE with empty, I get empty. The second example tells me that if I call all names -- element of F1, I get F1. Let's see. In that particular case, this would be F1. And what would this natural mutual recursion be? Remember, I'm reluctant to delete natural recursions or natural mutual recursions. Well, it would be all names -- LOE of empty, because F1 has no subs. And we already know that's going to produce empty. And that seems kind of natural. It seems natural to just cons F1 onto the natural recursion. That's also what this very complicated example was suggesting to us, was that you would cons the first thing onto the recursion. At this point, it's really clear that this function, the one that consumes list of element, has to produce list of string, so I'll get rid of that set of question marks, and I might even do this. Let me get rid of this note. Let's see, I'm almost done. I just have this case. This is a case where all names LOE is called with a list of elements that isn't empty. And we don't exactly have that case. Let's put that case in here. So let's say it's called with D4 and D5. Well, what's it supposed to produce? Well, it's got to produce everything in D4 and everything in D5 combined into a single list. And again, the way you combine two lists is with append. So that suggests that this should be append. Let's try running it. Check expect expects 2 arguments but found only 1. It's telling me that this is the whole check expect, so that's not right. I've got an extra parenthesis there. And whenever you have an extra parenthesis there, you almost surely are missing one a little farther along. There. Now let's try it. One of the tests failed. D4, F1, F2. So this produced, I'm just going to grab what it produced here. Actually, because I've got my screen small for recording, I have to be a little bit careful here. I'll slide this down here. I'll click here to see what test it is. I'll reselect this. So in this test for D4 and D5, it produced, oh, I have them in the wrong order. I just have my test examples in the wrong order. Because I asked D4 and D5, but over here I put the order 5, 4. Let's save it and run it. All 12 tests pass. Let's look at the whole function again. We'll delete this figure. Again, this was almost entirely following the how to design functions recipe that we've come to understand quite well now. The only wrinkle that came in because of the mutually referential types was that we had to design two functions. We had to think a little bit harder about what was going to be the base case test. We used a naming convention to have two functions of different names that operated on the mutually referential types. That's really about it. This is mostly an ordinary how to design functions problem with more complicated data.